structure and we plaster it with the loam sand, and by use the template, you know that the process, we make the required cavity and get the product by filling the liquid material in between it. Okay, and also in case of the skeleton pattern, big size, and we make the rib types of construction and fill it with the rough sand. Okay, so there are different types of patterns we use according to our requirement. And also at first we say that the dimension of the pattern, it's not just like the dimension of the product, there is some difference, and this is called the allowance. And there are different types of allowances is required to provide, like that the first one, this is called the shrinkage allowance. And why it is required to provide with the pattern, because we know that at the time of solidification, because liquid material will fill in between the prepared cavity, so when the liquid material solidify, at that time, for most of the materials, there are some exceptional cases, but for most of the materials, at the time of solidification, its volume shrink. Okay, its volume reduce. So if you make the cavity dimension just like the product dimension, okay, then it will, when the liquid material shrink, that means the product dimension will reduce and we cannot use it. Okay, so that's why it's required to make the cavity something larger with respect to the product. Okay, so and we make the larger cavity by providing extra dimension with the pattern, and this is called the shrinkage allowance. Okay, now the next one, this is called the draft allowance. Okay, in case of the draft allowance, what we do, we make that means the vertical portion of the pattern with some tapered shape, because you know that at the time of withdrawing, suppose this is the pattern and surround to this there are the molding sand. Okay, this is the pattern. Now when you withdraw this pattern from the sand, so with very little amount of that means tilting, there is possibility of breaking of the sand. Okay, it's very difficult to withdraw without any kind of failure or breakage. Okay, so for easy withdraw, what we do, we make it with some tapered shape. Okay, it's not like that, sorry. It's like that. Okay, it's like that. So when you make the pattern, it's like that, then what the advantage you will get? So if you consider some layer, suppose this one, this is the layer, so this is the dimension of the pattern, and you can also say that this is the dimension of the cavity. Okay, so at that instant both the layer match with each other. Okay, both the layer for the pattern and also for the mold. Now after some withdraw of this pattern, you will find there is the gap between the mold cavity and also the pattern in a particular particular layer. Okay, so in this layer, this is the dimension of the pattern after that much of amount of withdraw. Okay, so this is the dimension of the pattern, and there the cavity, this is something larger with respect to the pattern. So there will be little amount of gap, it will develop, and that's why you can say that it is comparatively easy to withdraw it without failure of the mold, without breaking of the mold. Okay, this is called the draft allowance. Now the next one, this is called the camber or distortion allowance. You know that. So there are some shape of the product is like that, where the exposed area on two sides of the product it's different. Okay, so suppose the shape of the product is like that U. Okay, so the outer exposed area, this is greater compared to the inner one. Okay, so where the exposed area is greater, that means there higher amount of cooling rate or solidification rate compared to the inner one. Okay, so when it will solidify fast, when it will cool fast, then what will occur? So there is imbalance of the, you can say that imbalance of solidification force. Okay, so due to that imbalance, because this is, you can say that due to higher amount of cooling, it will solidify fast, and at the same time, maybe it is in the liquid state or the liquid solid state. Okay, but it is in solid state. The outer one, this is solid state. So there is imbalance. So what will occur? So if you, if it will cool with that state, so it will distort. It's like that. It will distort. Okay, the shape will distort. So to compensate it, what we do? At the time of making the pattern, we make the pattern just negative to it. It's like that. Just negative to it. Okay, we make it like that. It's like that. So when distortion takes place, ultimately it will make the shape according to the requirement. Okay, so this is called the distortion or camber allowance. Now it's required to provide the machining allowance, because you know that the surface of the product, it will be very rough. So according to our requirement, suppose maybe the requirement is a very smooth surface, so it's required to machine it. So when you will machine it, that means there is removal of the unwanted material, so its dimension will reduce. So for getting the required dimension, it's required to make the product something larger. Okay, something larger with dimension. Okay, this is called the machining allowances. And also you know that at the time of withdraw, what we do, we at first enlarge the cavity by striking the pattern sideways. Okay, so when you strike it, then the cavity dimension will enlarge. Okay, so cavity dimension enlarge, that means the product dimension will also increase, which is not the requirement. Okay, so that's why what we do, we make the pattern with something lesser dimension. Okay, so that the cavity dimension can match with the requirement. Okay, so these are the different types of allowances is required to provide with the pattern. Okay, pattern is the replica of the job with some definite allowances. So these the discussion on the pattern. Now the next one, this is also one thing why we make discuss about the allowances. So another one thing, this is sometimes we use the master pattern. Okay, master pattern, what this is, master pattern means all the pattern, that means the materials are different, maybe it's wood or the metallic. Now if you use the metallic pattern, so this metallic pattern is also made by the casting. Okay, this metallic pattern, this is also made by the casting. So when you will make the pattern by, that means you produce this one by the casting, that means for making it, it's also required some pattern. Okay, and this one, the first one, this is made by the wood. Okay, so you use the pattern for making the product, this is metallic, but this metallic pattern, this also made by casting by using some another pattern. Okay, there are two patterns, so that means the allowances on the master pattern, this is 2 times. Okay, compared to the this is 2 times compared to the product. Okay, so these all according to regarding the pattern. Now next one, this is molding, sand and mold. Molding sand, you know that we already discussed about that. The molding sand, we say this is sand because it's not only the sand we use the material, it's not the sand only. Okay, there are some other materials you also use, but the major ingredient, this is the sand. Okay, you can say that most of the cases this is more than 80%. Okay, so this is the silica sand. So that's why we use this, use the term, this is molding sand. But other ingredients we also use, like you can say that some binders, okay, some fillers, and also the water. Okay, some organic binders, inorganic binders like the dextrine, molasses, linseed oil. Okay, and some fillers like the clay, this is the clay, and wood flour. Okay, and also the water. Okay, so these are the ingredients for making the molding sand. Okay, we say this is the sand because the major ingredient, this is the sand. Okay, silica sand. Okay, so there are different that means materials as ingredient with different percentage ratio. Okay, and according to that means percentage of the ingredients, the properties of the sand will also vary. Maybe suppose in some prepared sand, you can say that the moisture content is very high, and with respect to some another prepared sand, so obviously the properties will be different. Okay, so actually these ingredients define the properties, and the major properties we measure for the molding sand. Suppose this is the porosity. Now porosity depends on the ingredient. How? Suppose you use the sand, okay, with some particular grain size. Okay, the sand grain size. Now suppose the grain size, it's for 2 prepared sand. For first one, this is the diameter of the grain, this is D, and for the second one, this is small d. Okay, small d. Now if this diameter capital D, this is greater than the small d, so if you prepare the sand with that diameter, obviously the gap in between the grains, this will be greater compared to the small d. Okay, so ultimately it will increase the porosity. It will increase the porosity, that means the gap between the grains. Okay, so this grain size, and also you can say that the amount of the moisture and also the fillers like the clay. If the clay percentage is very high, you know that the clay grains, this is very less in dimension, so obviously it will fill the gap in between the grains. Okay, so its porosity will reduce, and porosity is a very important parameters with respect to the molding sand. Ultimately, you know that when you will fill the liquid material in between the cavity, what will occur at that time, the temperature of the liquid material is very high. Okay, with this temperature there is possibility of development of huge amount of gases and the vapor. Okay, now if these gases and the vapors, if it cannot release from its place easily, then what will occur? Then it will entrap in between the product itself. Now when the gas will entrap, then its quality will deteriorate. Okay, so that's why porosity is very important parameters quality for the quality product. Okay, so this is one, but you cannot increase this gap with very large amount, because if this will be very high, at that time also some other property will compromise with it, like the strength. Okay, like the strength. So there are different properties are important with respect to the molding sand, and these properties ultimately defined by the ingredients we use. Okay, so this is the discussion on the molding sand, and the next one, this is the mold. So in today's lecture we will mainly discuss about the topic, the gating system. Okay, the gating system. The